Hey guys, we did notes on these questions in class and notes on these questions. All right, so we're going to do the two in the middle. All right, so what's it say? It says, using the geometric description of rigid motion, transform the figure and predict if the rigid motion on the figure, given two figures, defines congruence. Okay, so in my notebook, so I'm going to add into my notebook pages my learning goal, right? So 2.6. Use geometric descriptions of, so using rigid motion, that means doesn't get bigger or smaller, stays the same size. So using rigid motion, can we use transformation? So any of those we discussed, can we use rotation, reflection, or translation to prove that if figure 1 fit on top of figure 2, then that would prove congruence. Okay, so that's what we're going to do under this learning goal. So let's take a look. Okay, so it's like taking this shape. How could it map on top of this shape? So either using your patty paper, what have you. You might notice we could say a vertical line. So what would transform it? Reflecting over a vertical line. All right, in class, some students called this the y-axis. That also would be true. We could call that our y-axis. Nice. So again, we're focusing on picking one or two questions on each page that you're like, you know what? If I got that question, I'd get it right. So let's look at question number 2. If we spun this, right? So if we spin this and now it's upside down, it would look like this, which kind of looks like our image over here if we moved it upside down. So it looks like if we spun it, we would get a rotation of 180. And so again, this is pointing up, and now this is pointing down. That would be a rotation of 180 degrees. Glide reflection. Okay, that means to slide. So if I slid it over here, and then I flipped it over. Well, if I flipped it over, then it would still be pointed in this direction. So that's not going to make it map on top. Rotation at 90. Okay, if I rotated at 90, it now, if I can think of this as kind of like a dog. Does that make sense? Now the dog is pointed down. So that's not going to, it's not going to point in the right direction. So if I reflect it across vertical and then horizontal, I think that'll fit. Okay, this other one, again, we have problems if I just rotate at 90. So let's look at the last one. If I flip it over a vertical line, now it's pointing this way, right? And then if I flip it from right side to upside down, that's going to fit on top. Okay. Which triangle is congruent? So we could use patty paper. Or we can use math. So probably using math is the best. So the length of KL means this length is the square root of 1 squared plus 3 squared. Okay. The length of this is, the length of this length right here would be the square root of 2 squared plus 4 squared. All right. And lastly, this length, the 3 and the 2, right? That's the square root of 1 squared plus 3 squared again. So whoever is congruent is going to have the same length of sides. It will need this longer side and 2 shorter sides, okay? So these are equal. So this is actually an equilateral triangle. It has 2 shorter sides, 1 longer side. All right, so let's take a look. This is 1 and 3, so that's good, but that's 2 and 1. So this is shorter. PR is shorter. We can see that with our eyes, but we can also see that kind of using our math techniques. Here, this is the square root of 2 plus 2 squared plus 2 squared. That's also shorter. SU is shorter. So it looks like our pick is going to be this one. Oh, I picked the wrong one. Okay, so I'm sorry. My apologies. I'm supposed to figure out which one is similar to this one. Okay, so let's dive in here. My apologies again. So this is the square root of 1 squared plus 2 squared. This is the square root of 1 squared plus 3 squared. And this is the square root of 2 squared plus 3 squared. So I'm looking for anybody that matches this same. So this one, it would be small. This one's the medium. And this one would be the longest side. So this one is 2, 1, same as that. So this is the same. This side's the same as this side. 1 and 3, we got 1 and 3. That's that median side. So that's that medium side, right? And then let's check this other side, a 2 and a 3. So a 2 and a 3 forms that hypotenuse, a 2 and a 3. So it definitely looks like triangle PQR. So PQR, I go across the long side and the medium, is congruent to the long side and the median, DEF. Okay. So who else? This one's too big because this is a 4 and a 2. That's too big, too long. This one we already proved was different, right? They don't have a 2 and a 4. Okay, so we found our answer. Nice work. Let's look at question number 4. The vertices of JKL are 5, 1, -2, -3, and -4, 1. Okay, under which transformation is the image not congruent? So anytime you take a scale factor, you're going to make it bigger. Okay, so I'm going to go to my notes. Rigid motion means doesn't get bigger or smaller. So that means no dilation. So that means when I see my x and y coordinate, I don't want it twice as big. So I want not this. Okay. Okay, what would rigid motion look like? Well, it would look like this. If I had a coordinate and I just translated it, it's not going to make it bigger or smaller. It just moves it to the left. So if I move something to the left, 5, now it's going to look like that. So I'm okay when I'm adding or subtracting numbers, but I'm not okay when I'm multiplying numbers. Okay, let's take back a look at this question. Which one would not be congruent? When you dilate, it's not congruent. Dilation means similar, not congruent. Okay, a reflection. Well, that would be fine. This would stay the same size. What about a counterclockwise rotation? Yes, rotation stays the same size. What about a translation? Same thing, stays the same size. So we picked the right answer, D. All right, let's look at 5. It says, which transformation would produce congruent figures? This is a big no, just based on the notes I gave. That's going to make the new image twice as big. So it's going to make it double in size. Well, that's not rigid motion. This will make it double. This will make it double. All right, so what's just going to slide? This is translation, so this is our answer. Translation is a form of rigid motion. because this one moved it 4 to the right and 3 down. Okay? All right, last question in this learning goal. A figure goes a translation, reflection, and dilation. Okay, so that means it got bigger or smaller. That's not rigid motion. All right, will the image be similar to the original figure? Yes, it'll be similar, absolutely. Why? When you shift it and flip it and blow it up, that's similar. So yes, and we'll eliminate these other ones. Yes, since only 3, no. I can flip it and spin it as many times as I want. Yeah, I think so. It's got to be B. Yes, any number of rigid motions and a dilation would produce an image that's similar. So what do I mean by that? Let's say I take a triangle and I shift it over here. Now, I need to try to make sure that it doesn't get bigger or smaller because translate just means shifted it over. Let's say I shifted it up and then let's say I flipped it over. It doesn't matter how many rigid motions I do, it's still the same size. Now let's say I blow it up. So if I make it twice as big, double this length, 1, 2, double the length, this length, 1, 2, double that length. Now I've done exactly what they said. Make a series of rigid motions and a dilation. No matter what, this will be similar because it has angles that are the same and sides that make the same ratios. All right? Nice work. Check out the next video for the next learning goal.